Okay, so this video is probably going to not be terribly long. Maybe it will, maybe it won't. But I'm hoping to get through a couple of sections anyway of the SAT stuff later today. We'll go over ACT eventually, and there's some, pre-cal stuff that you won't see and that we'll talk about at the time. Well, I'll get into all that, I guess, when I start that video. Okay, so properties of the standard deviation we may or may not have gone over before. It's the typical deviation from the mean. So when you see in an article somewhere that says that the expectation is, 72%, give or take 1.3, that means the standard deviation is 1.3. The value of the standard deviation, because we square everything and divide, it's either 0, which means that everything was the same and there were no deviations whatever, or it ends up positive. Outliers mess it up pretty badly, so that's why you really want things that aren't skewed if you're going to use the standard deviation. And the units are the same as the original data. So if the original thing was in inches, then basically with every deviation you had something inches minus something inches. So the result was something inches, and then you squared that after averaging those, so you ended up with inches squared on the variance, and then you take the square root and you have inches. So the units just kind of hang on. If you're really interested in what I just said and you don't understand it, then come to me and I'll write it out for you. Okay, so we already did that, and this. So, let's see, maybe we were here. Oh, no, we did that. Okay, so z-score is, I think, where I left off, basically. So a z-score is how far away from the mean are you, what's your deviation, and how does that compare to the standard deviation? So if we have this one, so the z-score is always going to be the value, gosh, that was weird, the value minus the average, so that might be like that, divided by the standard deviation, which might be that. So these are the same. X minus the average over the standard deviation. So a squirrel that weighs 3.2 pounds, so 3.2 minus, from a population of squirrels with a mean weight of 2.5, that's where the mean goes, and a standard deviation of 0.5. So this is how far am I away from the mean, and then how many standard deviations is that? So this one, we get 0.7 over 0.5. And this is positive because this value was bigger than the mean. If you have a negative z-score, it means you're lower than the mean. Now if we do this one, a gorilla weighs 360, so that's his value, minus the mean, divided by 45. I feel a bit like we already did this, but if you remember, I kind of did all of these and then had it deleted, so I may remember it from that and not from the videos I actually posted. So then the last question was, who has the higher relative weight, the squirrel or the gorilla? So if we look here, this was for the squirrel, this was for the gorilla. Because this one is larger, now that we've translated them basically to a standard unit situation, that's where the relative comes from. We're comparing them to their own groups. 1.4 repeating is bigger than 1.4. So we would say that the gorilla has a higher relative weight because the gorilla's z-score is larger than the squirrel's z-score. Okay, percentiles. I talked about quartiles. I talked about percentiles last time. We did this one. I can't remember if we did this one, so I guess I will go ahead and do it. Okay, so to calculate the mean and the standard deviation, just to save time on the video, I'm going to calculate the mean here in our studio. I'm going to name it C for cat. We're supposed to be 20. There are 20. Good. Okay, so we want mean. .08. Okay, so if we're doing this by hand, which you'll need to be able to do, remember that it's RMS in reverse order. This is a sample, so we'll divide by 1 fewer than 20, but it's essentially square, then mean, then root. So for the standard deviation, we first would take all the deviations. Okay, so we would make a list like that. I think at any rate, before you have to do hand work to turn in, well, you know what, after I finish this problem, I'm going to make one up that has something that's a little easier to deal with, because anything that they have you do that's timed, it's not going to waste as much time as doing these particular values, because they're crazy fractions. So I'll give you something that's easier to handle and then have you try to do that. But for this one, what we would do is take each and every one and subtract 10.08. So I'm going to do that here quickly in our studio, but again, you have to be able to do it. So I'm going to call this the deviation. D for deviation is going to be C minus 10.08. So now I have 20 values for D, and if you look at these, you get minus 4.38. That's the 5.7 minus 10.08. Negative 2.38 is 7.7 minus 10.08, and so forth. So I just have a new list that's now deviations. And then what I would do with those values is square them all. So I'm doing square, mean, root. It's RMS in reverse order. So I would square them all. So I'm going to say, okay, the square part is D. Where's the caret? Good grief, I couldn't see it. Okay, so now I have a new list of 20 values that have squared that. So it's square, mean, root, except that I can't do a true mean because this is a sample. So I have to divide. I think I tried this before to see if sum worked. Sum S divided by 19. Yeah, so that's the mean part, except not truly. If it was a population, you could have just said mean, D squared. Mean D squared is a little bit smaller, but remember, because it has a sample, we want a spread that's a little bit bigger. We want a little more allowance for error. So then, now that we've done S, we've done M, basically, that's the 3.556421, and then we need to do root. .856. So 1.86 is what we would get for the standard deviation. Okay. A cat named Daisy had a hemoglobin level of 7.8. We want her z-score. So we take her value minus the average over the SD. Okay, so that means that Daisy is 1.23 standard deviations below the mean, which is in a reasonable range, because remember, basically all values are between -3 and 3 standard deviations. 2/3 are between -1 and 1, but there's still quite a few cats outside -1 to 1. For the IQR and the fences, okay, so there are 20 values, which means the median is between these two. It's already in order for us, so that makes it a little easier. So since it's 10 here and 10 here, then the median, or Q2, is between 9.9 and 10. So we average them. And then Q3, since there are 10 of these, that means there will be 5 on either side. So once again, it's in the middle. So we count from the edges, basically, in. And it's between these two. So it's going to be 11.0 plus 11.2 over 2. And Q1 will be between these two. Okay, so now we have the Q1 and Q3, so we can do the inner quartile range. And that means that the amount that we go out from either side is 1.5 times 1.95. 2.925. So we're going to start at Q1 and subtract that much. And we'll start at Q3 and add that much. So 6.225 and 14, was it 0.015? 0.025. So these are our fences. I don't know how to make that thing go away. Ugh. Okay, so those are our fences, 6.225 and 14.025. And the IQR is 1.95. And then there was the question of the outliers, and I just erased what I'd written, but the fences are still here, 6.225, 14.025. So if we look here, it looks like this 5.7 is the only outlier. And this is so terribly familiar that I do think I did this in the other video, but that's okay, we'll live. Okay, so again, if the distribution is symmetric, you should be using the mean and the standard deviation. If it's skewed, you want to use the median and the IQR. And if you're comparing symmetric and skewed, then you want to use median and IQR because those are similar. They work for symmetry. It's just that they're not as tight a control. But the mean and standard deviation do not work for skewed. So if you have both. Okay. Box plots and the 5-number summary. I talked about this last time, the 5-number summary. This is the thing actually we're going to do with our, at this moment, with our infection data. So you have the minimum value, the maximum value, and the quartiles. And when you draw it, basically this is the minimum, quartile 1, quartile 2, quartile 3, maximum. So this line represents 25%, this length does, this does, and this does. So it's split into 25%. If you have an outlier, you don't go all the way out to it. So if really there was an outlier out here, but then the other last value was right here, you would just stop this line here and go put an asterisk out there. And that's how you mark. That's why it used to be called a box and whisker plot. These being the whiskers, I guess, but then you put the asterisk for an outlier. Okay, so we want to create a box and whisker plot for, oh, this doesn't work for us. Let's pretend I'm going to pretend that I found the birth years, months, the birth months for a bunch of people. And let's say I did 1. So let's say that was the first set. And then let's say that the next class was
Sirius XM's Coffee House.
Ed Sheeran, Tenerife City.
What the heck? One of these days I'm going to figure out how to close these things. Okay, so that's a 5. For May. Let me just... Okay, so let's say that was one class and that was another. The first thing that I need to do to create a box plot is to put them in order, unless I'm using RStudio. So I'm going to do one of them by hand, and I'm going to do one by RStudio, because you can use RStudio on the stuff you turn into me for sure. If you need to create a box plot on a handwritten portion of an exam, though, you're going to need to be able to do this by hand. So I'm going to look at the first one. Well, I guess I'll look at the second one while I've got the blue. So I look through, and there's 1. There are no 2s. There's 1 3, 2 4s, 1 5, 1 6, 9 9, 10, 11, 11, 12. I have 1 2 3 4 5 6 7 8 9 10 11 12 of them. So there's going to be 6 on either side. And I land in the middle. So the average of 6 and 9, so 7.5. Then there's 6 over here, so there's going to be 3 on either side. So I land in the middle of those two, so 10 and a half. The middle of those two stole 4 because there are 2 of them. Min, max. The interquartile range is 6. I can't even go 6 once from these 2 values and stay within the realm of reality, so I certainly can't do it 1.5 times. Generally speaking, birth month is going to be like a uniform type of distribution, so it's not going to be skewed enough to have an outlier. Okay, so my 5-number summary is, I'm going to, so 1, 4, 7.5, 10.5, 12. Take this over here. So I'll just name this X. Okay, so I would just go 5 num X. 1, 3, 6, 10, 12. In RStudio, I can also say box plot X. So see how it's got that little bar on 12. Of course, we don't use bars normally. We just end there. This one ends at the minimum, 1. This is at 3. This is at 6. This is at 10. So it's in line with these. Okay, so 1, 3, 6, 10, 12. Okay, so if I have a scale down here, okay, that's 12. Now, always label this as though it's an x-axis. Don't skip any values at all or your box plot won't be good. So the purple one starts at 1 and goes to 3. But let me do this. What I normally do is go ahead and draw the lines for 3, 6, 10. So 3, 6, 10. And then make them into a box. And then go out from there to 1 and to 12. Okay, and then this one, 4, 7.5, 10.5. Still out to 12, and still down to 1. Okay, so the distribution was generally to the right. So those people were born generally later in the year on the blue side. I just realized that I forgot to do what I told you I'd do, which is come up with something you could calculate the standard deviation more easily that would more likely show up on one of these exams. And you can use a regular calculator, you just can't use the statistics function. Because if you use the statistics function, you'll be able to create a list and say, tell me the SD. And then you will have written down nothing. And there's a pretty clear rubric, and you do have to write down the steps. So let's say the numbers were okay, so I think I've made this where the average is 5. So you would just add these up. So 9, 13, 21, 23, 28, 35, 38, 44, 50. Okay, so that sum, you could have, of course, put in a calculator, but calculating the mean is going to be looked for probably all the way to this extent. You have to have the mean before you can know the deviations from the mean. Once you've calculated that, then you calculate the deviations. Because remember, it's a standard deviation. So 4 minus 5, 5 minus 5, 4 minus 5, 8 minus 5, 2 minus 5, 5 minus 5, 7 minus 5, 3 minus 5. And all I'm doing here is taking this list and subtracting 5 everywhere. So I get negative 1, 0, negative 1, 3, negative 3, 0, 2, negative 2, 1, 1. And if I just added these up directly, I would get 0 because the numbers are going to balance with the mean. But once I have the deviations, then I go SMR, right? So S, I'm going to square them all. Then M, but not really, because I'm going to divide by 9, assuming this is a sample. So divide by 9. So that's 30 over 9, which is 10/3. And then for the S part, so this is the variance. If you're asked for a variance, you stop right there. This is the standard deviation, is when I take the square root of that. I'm sorry, this shouldn't have been S, this should have been R. So RMS. Okay, so this is how you would calculate it by hand. If you wrote all of this down, you'd be golden. If you're not being asked to turn in handwork, then just do it in R if you have R open. Okay, so these are examples of how a box plot and a histogram will have stuff in common. If you're skewed to the right, then you have a long tail. You're going to have a tail on the box plot also. Symmetric is still symmetric, and left skewed is still a long tail on the left. So if we wanted to know the median of this variable, we just come down, and it looks to me like 16 probably to the nearest integer. The first quartile of variable y, so the first quartile is the first line. I'm going to say 22. And the question of which one has more dispersion is how it's spread out. So this one has a longer range. Sorry, this one has a longer range going from about 9 to about 38. So almost 30. And this one goes from 4 to 29. So that's 25. But also, the length of this box is longer. So this one's way skewed, and this one's not really, even though it has an outlier. So this one's spread out in both the box and the thing. But remember, because this one's symmetric, we might use the mean, but it would be close to the median, and we would use the standard deviation. In this one, because it's skewed, we would be using the IQR and the median. But also remember that if you're comparing two, and one is symmetric and one is skewed, then what you're going to do is use the median and the IQR in both cases. So IQR is the dispersion question. So this one has a longer box than that one, which means its IQR is bigger. So Y has more dispersion. X does have an outlier. You can see it right there. And it is 29 or 30. And the shape of the variable Y is skewed left because it's longer on the left. Okay, so that's the end of the notes from this one. Sometime this week I probably need to get on to some other topic and create some videos, but right now I'm going to work on the test prep.